Hello, everyone. Today we are going to be discussing hurricanes. What is a hurricane? Some of you may have heard one of the following three terms: hurricane, typhoon, or cyclone. All three of these words refer to the same type of storm mass. Formally, a tropical cyclone is a huge rotating mass of low pressure characterized by strong winds and heavy rain. They are the largest storm systems on planet Earth. In North and South America, tropical cyclones are called hurricanes. In the western North Pacific Ocean, for example near Japan, they are called typhoons. Lastly, in the Indian Ocean, they are called cyclones. Because we are in North America, we refer to them as hurricanes. The one key difference lies in the fact that south of the equator, hurricanes spin clockwise, while north of the equator, hurricanes spin counterclockwise. No matter what they are called, hurricanes can be highly destructive due to the massive amount of energy condensed into these storms. Depending on the size of the hurricane, it can release the same amount of energy as the thousands of atomic bombs. In fact, the energy contained in a single hurricane is greater than that generated by all energy sources in the US over the past 20 years.
Hello, my name is Noor. So, to carry on with our topic, hurricanes, cyclones, and typhoons are all devastating wind powerhouse effects that cause catastrophic results within society. However, we are focusing on hurricanes today, so I'm going to be touching upon how hurricanes form, when they form, and the places they form. Hurricanes essentially suck heat from waters located in the tropical latitudes of the ocean as a method to fuel their power. The storms initially begin as a tropical wave, which is a low pressure area that moves through the moisture-rich tropical regions of our world. And these factors enhance thunderstorm and wind activity. As the weather system progresses west across these tropical regions, as I already mentioned, warm ocean air rises due to direct heating from the sun, forming an area of low pressure underneath. This basically causes the occurrence of more air to circulate. Once the air rises, it cools at high distances, forming clouds and enhancing thunderstorms in the process. Eventually, the water trapped in the clouds condenses and forms droplets, releasing even more heat to power the storm that is already present. Basically, all these hurricane factors originate from warm air rising up from the ocean, and if the atmosphere is just right for their formation, they can grow very large and be very devastating. Specifically, hurricanes need warm ocean temperatures, usually above 26 degrees Celsius, and there needs to be some bending/shifting effect from the wind, which can be called the Coriolis effect, which is an entire different topic of itself, which can be explained at a different time. So, because warmer oceans are essential to creating hurricanes, the temperature of water is important to understand. Ocean density, which basically talks about ocean mass, is affected by ocean temperature and ocean salinity, which is like the saltiness of the water. Hurricanes cool the ocean by acting like heat engines that transfer heat from the ocean surface to the atmosphere through evaporation, therefore cooling the oceans below once it's taken all away the heat from the surface of the ocean. To understand why hot waters are usually located on the surface of the ocean and why deeper parts of the ocean are usually more cold and more salty, I'll present to you a density exercise to make things clear to you. Here is a glass of water, and this is an ice cube. Although ice is cold, it is known to be less dense than water, therefore it floats and stays towards the surface of the ocean, in terms of like giving an ocean example, but here I'm giving you a glass of water. So look what happens when I drop the ice cube in the glass of water. It immediately floats to the top. The water that is beneath the ice is more dense, which means it's therefore it stays below the ice. While the ice itself is less dense, which is why it floats at the top and stays there. Like I already mentioned before, deeper ocean water is much cooler and much more dense. Hotter waters are located at the surface of the ocean, towards the top. Therefore, hurricanes can easily pull the heat from the surface of the ocean to help grow their power because the heat is right underneath them. Besides going through a difficult process of trying to pull heat from deeper parts of the ocean if that ever occurred.
We are now going to go through a series of 3 questions in which I will pose the question to you all, ask you to pause the video for a short time, write down your answers on a sheet of paper, then return to this video to hear the correct answer and explanation from myself, and write down that correct answer as well. Draw from what you have learned from us so far, as well as your previous knowledge of hurricanes. All right, let us begin. The first question I have for you all is, what is the ideal water temperature for hurricane formation? Now you can just pause the video and write down your answers. All right, I hope you all have your answers. The correct answer is that hurricanes form in water that is high in temperature because their formation is strongly dependent upon high sea surface temperatures. Places where ocean temperatures are sufficiently warm to generate hurricanes are in the subtropical and tropical areas of the world. Studies of hurricane formation and tracks suggest that an ocean temperature of around 82 degrees Fahrenheit or 28 degrees Celsius are necessary for the formation, intensification, and sustenance of hurricanes. Moving on to the second question, what type of air must be rising in order for a hurricane to form? Go ahead and pause the video and write down your answers. All right, the answer is that warm air or water vapor must be rising above the ocean in order for a hurricane to form. When ocean temperatures are warm, great amounts of water are evaporated into the atmosphere. In order for a developing hurricane to have a continuous supply of water vapor, the ocean temperatures should be warmer than 82 degrees Fahrenheit or so, not just for the thin surface layer of the ocean, but through a good depth, around 100 meters or so. This ensures that the mixing of the ocean waters by the strong winds associated with the hurricane will not bring the colder waters to the surface and interrupt the supply of water vapor. The third and last question, where do hurricanes most often form? Go ahead and pause the video for the final time. All right. The correct answer is that hurricanes most often form in the tropical and subtropical regions of the world because these are the regions with the warmest sea surface temperatures, which are advantageous for hurricane development. Common places include the North Atlantic Ocean, for example, near the Gulf of Mexico and near Florida, the Northwest Pacific Ocean, for example, near Japan and the Philippines, and in the Indian Ocean, for example, near the Bay of Bengal and the Arabian Sea, the two bodies of water bordering India. Hurricanes are known to be highly dangerous and destructive. Destruction from hurricanes is often caused by high wind speeds and flooding from intense rain. A hurricane can dump 6 inches to a foot of rain across a region. However, the major cause of many hurricanes' coastal destructions are through what are known as storm surges. As the hurricane's hill of water migrates towards the shore, the winds from the hurricane push the water onshore, causing a huge rise in seawater level near the coast. These storm surges can cause intense flooding and damage to large amounts of property. The overall impacts of destructive hurricanes on society are drastic. First and foremost, they often lead to the loss of human life. especially in poorer regions and island communities, for example, Puerto Rico. They also cause immense economic damage to a community. Of course, they destroy countless buildings, equipment, and supplies, but they also significantly reduce economic output, often lead to an increase in unemployment, and they can cause shifts and scares in the stock market. In fact, hurricanes cause more economic losses than any other type of natural disaster in the US.
So, I'm sure you all know the devastation a strong hurricane can cause. What we need to do as a society is to develop ways to prevent them from ever occurring, or at the very least, from growing powerful. Pollution is a factor that contributes to global warming. As we use more vehicles, more factories, and other emissions of carbon dioxide, we are essentially breaking apart the ozone layer, which is a field around the Earth that protects the Earth itself from overheating from the sun. As we are emitting more pollution and the ozone breaks apart, we are allowing more heat to enter the Earth and the planet's atmosphere, and which ends up heating up the ocean's temperature, overall temperature, very minorly, but it still does it anyways. Therefore, knowing this, the most efficient way to help minimize the occurrences of hurricanes is to lower our pollution emissions as a society. For example, completely electrical cars are a sign of improvement in terms of positively affecting the environment, instead of using normal cars that emit heavy bases of CO2. That's all I have to say for today. Thank you all.